So in this video, we're going to look at another form of a circle. And we'll start off with an example. So we're going to try to graph or sketch the graph of this function x squared plus y squared plus 6x minus 4y minus 3 equals 0. And this looks like something we haven't really dealt with before. We've graphed functions before, but we haven't graphed one in this form before. Some simpler forms we have seen are things like this. So if I wanted to sketch the graph of 2x plus 3y minus 12 equals 0, one possibility is rewriting this in slope-intercept form. So I'll start off with my 2x plus 3y minus 12 equals 0. I will work to get the y by itself, so add 12 to both sides, and get 2x plus 3y equals 12. Then I'll subtract 2x from both sides. The 2x and the 12 are not like terms, so I will leave them separate. I could write this as 12 minus 2x, but that's a little bit further from slope-intercept form, so I'll write this as negative 2x plus 12. And then I'll just divide everything out by 3, and I'll get my slope-intercept form, y equals negative 2/3 x plus 4. And so right here we have our slope, we have our y-intercept. I start by applying the 4, and then I can follow the slope of down to right 3, down to right 3, down to I'm off the graph, or up to left 3, up to left 3, and from that we get our line. So this is a linear function here. Now, this had no squared terms. This had 2. So let's get closer to something we've done before, or with something we've done before. I could sketch the graph of this, where I have an x squared but no y squared. And like before, I'm just going to get the y on one side by itself to start off. So I will add the y to both sides, and so I will be left with x squared minus 6x plus 13 equals y. Or if I switch these two, put the y on the left, put this on the right, which is closer to what we usually see, I get y equals x squared minus 6x plus 13. Now if I had a graphing calculator, this would be exceptionally easy to graph. I could put this in, plot some points, I'd see the curve. I know it's quadratic because there's an x squared term. But in order to get close to what we're eventually going after, which is graphing this, we're going to go back and complete the square. Now there are two ways I've seen to complete the square. The strictly algebraic way, which is not the way most of my students end up doing it, is look at these terms and say, okay, I have x squared minus 6x. I need to figure out what I need to put here to make a perfect square. And the sort of method is I do the b term over 2 squared, which is negative 3 squared, which is 9. And so I need a plus 9 right here. And I'll get to x squared minus 6x plus 9 minus 9 plus 13. So I can't just toss a 9 in here randomly. I have to sort of counteract it with a subtraction of 9, and this would reduce to x minus 3 squared. This would combine to plus 4. So that is the way we would do it algebraically. Most of my students do it graphically or geometrically, saying, okay, I have a positive x squared, and if I want to make a square, I have negative 6 x's. So in order to make a square, I'll put 3 x's on this side, 3 x's on this side. I notice that I am missing, to make this square, 9 ones. And so I'd end up with the same thing. I would have from here, x minus 3 squared. I am missing 9, and I have this 13. And so I get the same answer. I get the vertex form of this equation, x minus 3 squared plus 4. Knowing that this is vertex form, there's h, there's k. My vertex is at positive 3, 4. And I plot that point, 3, 4. And I can use my knowledge about a quadratic to know if I go over 1 in either direction, I go up 1, because there's a positive 1 coefficient right here. If I go over 2 in either direction, I go up 2 squared, which is 4. And there's my parabola. So this is all stuff that's been done before. Now let's finally get back to the problem we're dealing with, which is x squared plus y squared plus 6x minus 4y minus 3 equals 0. So we will complete the square twice. We'll complete the square once for the x terms, and we'll complete the square a second time for the y terms. And then we'll bring it all back together and end up getting a circle in standard form. So let's deal with the x's. I'll do it in the graphical sense or the geometric sense, even though you can do it algebraically. So I have an x squared. I have positive 3 x's on each side to make a total of 6. And I'm missing 9 x's there, which means I would have x plus 3 as the dimensions of my square, but I'm missing 9. Similarly, for the y, I have 1y squared, a total of negative 4 y's, which means to make a square, I'll put 2 on either side. And from there, I would be missing 4. And I guess a note on this, I am missing a positive 4, so I will have a minus 4 down here, because negative 2 times negative 2 is a positive 4 in this corner. And so for my y's, I get y minus 2 squared minus 4. And now I'll just bring everything else from here down. So I have a plus between these terms. I have a minus 3. I have an equals 0. I'll combine negative 9, negative 4, and negative 3 to get negative 16. I will bring down my x plus 3 squared and my y minus 2 squared, make that equal 0, and add 16 to both sides. And I get x plus 3 squared plus y minus 2 squared equals positive 16. This is standard form of a circle. If you don't know what that is yet, there's a video that will be one before this in the playlist, but that would be x minus h squared plus y minus k squared equals r squared. Notice the minuses means I'll switch the sign. So the center of my circle is at negative 3, 2. The radius is the square root of 16, so the radius will be 4, so I will go up 4, left 4, down 4, right 4, and from that I can draw my circle, and I get this. Okay, so let's define what we're dealing with, come up with a method in general, and see a few more examples. So the general form of a circle is just x squared plus y squared plus ax plus by plus c equals 0. And it's geometrically, graphically, not the useful form, but sometimes algebraically, this can be useful for dealing with the strict numbers and distances and um, algebraic machinations of this. The way we're going to deal with this to graph it, so to graph, all we'll do is complete the square for x and y, and then graph from standard form, which we dealt with in the previous video. Now, most of the examples you'll see in a school classroom are going to work out nicely. You'll get perfect squares, the completing the square will work out nicely. That's not always the case, but you'll see 2 of the 3 examples work out very beautifully, and the third example isn't that difficult. So let's go through, see a couple examples. I would recommend looking at the problem, pausing it, trying it, and then seeing what happens instead of just passively watching. But I will go through it and we'll see how this works. So, same as before. I deal with my x's, I deal with my y's. So for my x's, I have x squared plus 4x. I will say, okay, I have a positive x squared. I have 4 total x's. That means 2 on each side, which means I am missing 4 in this corner. So completing that square, I get x plus 2, a positive 2 because there were positive 4 x's, squared, but I was missing 4 right here, so I'll put a minus 4. For the y's, I had y squared plus 2y, and so I have a single y squared, 2 total positive y's, so I'll put 1 on each side, and you can see I am missing 1 unit from this corner. So this, when I complete the square, becomes y squared, nope, not y squared, y plus 1 squared minus 1, and I'll bring down everything else. One more comment about completing the square, just in case you're wondering what the heck's going on. What we've done is taken this expression here and written an equivalent expression. If I were to expand this out, so I'll write that over here, I would get x squared plus 4x plus 4 with this minus 4, and you can see that it is equivalent. So we are just taking what we have and writing it in a different form that allows us to figure out what we're actually doing and graph it. Okay, wrapping this up, I'll bring down the x plus 2 squared. I'll bring down the y plus 1 squared. I'll combine the negative 4, negative 1, and negative 20 to get a minus 25. And I will add the 25 to both sides to get the standard form, x plus 2 squared plus y plus 1 squared equals 25, meaning that my center is going to be at negative 2, negative 1, again, changing those signs, and my radius is going to be the square root of 25, which is 5, so negative 2, negative 1, and then 5 in each direction, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and draw the circle. Okay. 2 more examples. This one looks simpler but can be confusing, so we'll go through it. I'm going to complete the square for the x squareds. There's only an x squared. There are no x terms. I'm going to complete the square for the y squared. There is a y squared minus 8y. And notice, I just have an x squared. It is already a square. I don't have any x terms that need to be accounted for on the sides. So in completing this x squared, I just have x squared. There's no missing piece in this corner. For the y squared, I have a positive y squared but negative 8y's, which means 4 on each side. I am missing 16 units in this corner, so I would have y and a negative 4 each side, so y minus 4 squared, then missing the 16, minus 16, and I'll bring down everything else. There really wasn't much. I'll have a plus between these, and it equals 0. So let me rewrite this. I have x squared plus y minus 4 squared minus 16 equals 0. Add the 16 to the other side. X squared plus y minus 4 squared equals 16. And then my center. Notice there's nothing added or subtracted to x in this square, so my x coordinate is 0. I have a y minus 4, so the y coordinate is a positive 4, and the square root of 16 for my radius is 4, so I have the point 0, 4. And from there I go up 4, from that point I go right 4, go down 4, and go left 4 to make my circle. I guess I'll box in the standard form. That's what we're using. Okay, last example. Doesn't work out quite as cleanly, but that's fine. So same process. Bring the x's together. So I have x squared minus 8x. Bring the y's together. I have y squared plus 4y. So in here I have a positive x squared. I have a total of negative 8x's, which means negative 4 on each side. I am missing 16 units in this corner. For the y's, I have 1 positive y squared, a total of 4 y's, which would mean 2 on each side. And I'm missing 4 units in this corner, so I would have x minus 4 squared minus the 16 missing units plus y plus 2 squared minus the 4 missing units. And then I bring everything else from my equation, so I have this plus 10 equals 0. Combining like terms, negative 16 minus 4 plus 10 gives me a minus 10. I still have x minus 4 squared plus y plus 2 squared. I will add the 10 to both sides, and I will get x minus 4 squared plus y plus 2 squared equals 10, which is our standard form of a circle. And from this, I can see the center will be at 4, negative 2. But the radius will be the square root of 10. And if I grab a calculator, I can see that is approximately 3.1. So this is just one way that it can be not quite as clean. So I plot my center for negative 2. And from that center, I go up 3.1, down 3.1, left 3.1, and right 3.1. So 3 and a little more, 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 and draw the circle. Okay, I hope that helped out. Again, if you are not familiar with graphing this form, the standard form of a circle, look for, I have a video up already about how to graph this, and there will be a link to a worksheet so you can get some practice on these in the description below.